Hello, welcome to my poster. My name is Shiri Makov and I study auditory attention. So, generally, we could say about the field of attention research that it mainly focuses on how do we attend. And what interests me most is maybe the other side of the same coin, and this is how do we ignore? Or specifically, does the brain do anything actively to allocate attention away from things that are just irrelevant or distractive. And this is exactly what we tried to test here, and let me walk you through, and later I'll be happy to meet you and ask and answer more questions in case you have. So the design was pretty simple. This was an MEG study with 20 participants. They were presented with a dichotic listening task. They were instructed to attend to the left ear, where they were presented with a stream of tones at a fixed rate. Every once in a while, there was a target that was slightly different in pitch, and they were asked to respond in a button press. Meanwhile, they were presented to a stream of tones to the right ear that they had to ignore was a distractor stream, and it was either rhythmic at 2 hertz or non-rhythmic. So attend left, ignore right, and recorded by Meg. The behavioral results show here at the top basically that both distractors were destructive, right? With lower hit rates, for rhythmic and non-rhythmic distractors compared to no distraction, higher false alarm, and longer reaction times. But the thing that is interesting is the difference between the different distraction types, right? And here we see higher hit rates when the distractor was rhythmic compared to non-rhythmic. So basically we can say that rhythmic distractors are easier to ignore. Now let's see the MEG results. So here we see the effect of the distraction on the attended response. Now, you remember we said that the task was attend left, and there was a stream of tones at 1.6 hertz. Now, here we see the power spectrum of the neural response showing a very nice peak at 1.6 hertz, at the attended rate actually. And this is the response to the attended tones. Now, this response was evident regardless of distraction type. However, when there was no distractor, this response, the attended response, was more bilateral than there was rhythmic or non-rhythmic distractors. Another thing that we see here is that when the distractor was rhythmic, the response to attended tones was larger over the contralateral hemisphere. And here we can see the comparison, rhythmic versus non-rhythmic distractor. We see higher activity over the contralateral hemisphere. So when there was a distractor, it affected the way the brain responds to the task in a way that rhythmic distractor allowed for a higher response to the attended tones. So if we recap, we saw earlier that rhythmic distractors are behaviorally easier to ignore. And here we see that they also allow for a better representation of the attended tones. So here I actually relate to the neural response to the distractor tones themselves. They were either rhythmic or non-rhythmic. And here we see, first of all, we see a baseline shift, kind of an elevated baseline when the distractor was rhythmic versus non-rhythmic. And we see it here over multiple temporal areas and going back to TPJ in the contralateral as well as the ipsilateral hemisphere. So we interpret this as a mark of anticipation for distractor tones when they could be anticipated. And this was followed by a later decreased response to the distractor tone. This was also bilateral and evident over auditory areas. So here we show that distractors could be anticipated in a way that supports performance. And these findings suggest that temporal predictability not only serves to enhance the processing of attended stimuli, as suggested by dynamic attending theory, but also that temporal predictions could be utilized to more effectively ignore task irrelevant stimuli. So, thank you for listening, and I'll be happy to meet you, hear your thoughts, and answer questions. Bye bye.